Hi, my name is Amber Huffman, and today I'm going to take you under the hood of NVMe. So we're experiencing an explosion in data in the data center. Many of us talk about it in gigabytes, but the explosion of data is so big that it goes to terabytes, then to petabytes, then to exabytes, and now we're even hearing talk of zettabytes. It's huge. And so one of the big challenges that we have is how do you deal with all of that data? Solid-state drives are great, but what you see in the market typically today is they're based on serial ATA and SAS. Those are legacy technologies that were designed for hard drives. If you really want to take true advantage of SSDs, you need to get on an interface that is architected for SSDs, and that interface is NVM Express. NVM Express is the standard for PCI Express solid-state drives. NVM Express not only brings you huge performance with a bigger pipe, but it's also bringing it to you faster. So it's taking that SSD, attaching it directly to that CPU, and giving you low latency and a huge amount of data all at once. At Intel, we compared our best-in-class NVMe SSD versus our best-in-class serial ATA SSD. We were blown away. Our NVMe SSD delivered 6x the performance of that SATA SSD. Performance numbers are really exciting, but in a business, you need to deliver performance in a way that matters to your end user. We looked at an application called the Oracle x10 database. It's an in-memory database that is huge, and you have to load the entire contents of the database into host DRAM. To get it into DRAM with hard drives takes 30 minutes. With SATA SSDs, it takes you 4 minutes. With NVM Express, it's less than a minute. In 2014, NVM Express invaded the data center. In 2015, NVM Express is coming to the client. NVM Express has started out with PCI Express add-in cards as well as 2.5-inch form factor devices. One of the exciting things as it comes to client is you're going to start seeing NVM Express in the M.2 form factor as well as in BGA form factors, where it's just a single chip. This is what really unlocks putting NVM Express in tablets and in phones. We have evolved as an industry, and now PCI Express delivers great power benefits. As we move into the client, power matters. It's not just about performance. Now, if we look at storage, 95% of the time you are idle. What's really important is when you are actually transferring data, that you transfer it quickly and you quickly race back to idle. So if you're comparing against a SATA SSD, you can get much higher performance with equivalent power. The next frontier we're looking at in NVM Express is fabrics. We love PCI Express, but the benefits of NVMe can be felt across other fabrics like Ethernet, Fiber Channel, InfiniBand, and OmniPath. This is important whenever you have hundreds to thousands to millions of SSDs. And so when we look at extending it to fabrics, how do I get the performance of my NVMe SSD like it's in my laptop, even when it's across the data center? We use the NVM Express protocol all the way from the CPU, across the fabric to the end device. Our big goal with NVMe over fabrics is less than 10 microseconds of additional latency across that data center or across the world. By adopting NVM Express, you're making a strategic investment in your data center that's going to last you for a decade. It is unlocking the performance, the low latency, the low power, and the features you need for your storage, whether it's in a laptop, all the way to an enterprise data center. To learn more about NVM Express, check out nvmexpress.org.